In this video, we're going to create a new function by using composition of functions. It says for the functions f of x equals 4x plus 3 and g of x equals 2x squared plus 5x, find f of g of x. A lot of people struggle with this notation, f of g of x, so what I like to do is I like to write it in a better way. This circle usually gets thought of as a multiplication. It is definitely not a multiplication. This means of. So we're going to write this as f of g of x, which is equal to f with an input of g of x. So basically, when you see this notation, x is being input into g. So x is input into g. And then we take g and we input it into f. So we'd write g is input into f. Kind of got those a little close together. Hopefully you get the idea. So what we're doing is we're taking the g function and we're plugging it into f. The g function is 2x squared plus 5x, so I'm going to replace g of x with what it is and write f with an input of 2x squared plus 5x. Now what you need to think of here is, what if this were f of 4 and I replaced all this in here with just the number 4? Well, everybody would probably take the 4 and plug it into the f function for x, and you do 4 times 4, which is 16, plus 3, which is 19. But when we put two terms together, we start to freeze up because we're not sure what to do with it. Well, we're doing the same thing. We're going to take this input, which was g, 2x squared plus 5x, and we're going to input it into the f function for the x variable there. So that's going to look like 4 times all this that's being input for x, so that's 2x squared plus 5x, and then we add the plus 3. So this whole piece here under there was x in that equation. So we just replaced it with what g of x is. And now we can evaluate by distributing. That's 8x squared plus 20x plus 3. So this is what f of g of x is. And we're ready now to use this equation. If they ever asked us what f of g of 2 was, we could plug in 2 for the x values and be able to evaluate that.